Hello, everyone. Again, I welcome you all for the next session. Ms. Kinjal Patel. She is a data and AI specialist with expertise in machine learning, natural language processing, and large language model application. She has delivered impactful projects in deep learning, computer vision, and generative AI, driven improved decision making, automation, and operational efficiency. Her research focus span applied AI for the education, healthcare, and sustainability, including predictive modeling for the water resource management, medical imaging, and multimodal AI system. She has contributed to the scientific community through the Scopus Index journal publications and conference papers. Recognized with the Best Paper Award for AI driven predictive modeling, she has also received industry and academic recognition, including Industry Project Expo Winner Advice, 3 times LinkedIn Top Voice in the Data Science, AI, and ML, a fully funded Isaac set, and 21st All India rank in NCAT. With a strong foundation in the both academic research and industry project, she combines technical expertise with the applied problem solving to deliver scalable AI solution for real world challenges. So I welcome Ms. Kinjal Patel to deliver the session. Ma'am.
Thank you, ma'am. Very good evening, everyone. Am I audible?
Yes, ma'am.
Okay, okay. So very good evening, everyone. Welcome to the session 10 of Atal Faculty Development Program on Smart Health AI Solution for Modern Healthcare Systems, conducted by Vidush Somany Institute. I'm Kinjal Patel, currently working as a data scientist at Billiard Services, Melbourne, Australia. And today we will explore AI in preventive healthcare using data to stop disease before they start. Over the session, we will move from the basic of preventive healthcare to real case studies, challenges, and practical strategies. We will move from high level concepts, what preventive healthcare means and why it matters, to concrete AI algorithms, real case studies from imaging to population health, and the practical challenges of taking models into clinical practice. So my goal is that by end of this session, you will leave with a concrete idea you could apply in teaching, research, and clinical collaboration. So moving forward, so this is the today's agenda that we will going to discuss. So here is the roadmap of the session. We will define preventive healthcare and why it matters. We will explore common diseases across different ages, then cover 3 levels of prevention, and then we will compare mental and physical health, identifying core requirements at um, healthcare data sources, and then we'll dive into AI algorithm used in healthcare, and total of 5 healthcare studies we will going to discuss. And then we'll finish with some implementation related challenges and the final strategy, AI adoption and open discussion. So this will give you the big picture from the theory to practice. I want this session to be very interactive. I just would like to ask few questions. What do you mean by preventive AI or preventive healthcare in your thoughts, audience? Anyone?
Ma'am, before getting and disease, if we are taking any precaution,
Mhm.
then it will be considered as a preventive measures. So preventive Hey, that on might be.
Perfect. Perfect. So, moving forward to understand what is the exact meaning of preventive healthcare, uh, so we can say it is considered as let's start by really unpacking the meaning. And when you hear the term healthcare, many people immediately think of hospital, doctor, and treatments, but preventive healthcare flips that particular script. Instead of waiting until someone is getting sick and the condition is getting very worse, we use knowledge, technology, and the behavior changes to keep them healthy in the first place. So, predictive analytics and preventive healthcare both include all action to stop the disease or slow it down or detect it early as soon as possible before it getting so worst, right? So we can say preventive healthcare is just the proactive approach that solemnly focus on maintaining health and preventing the disease rather than simply treating out after it occurs, right? So yeah, as you said, like stop it before it is getting started or getting worse through the early detection, targeted interventions, and lifestyle modification programs. Designed based on such risk factors, preventive healthcare reduces the disease burden and improve the population wellness. For example, vaccination, regular health checkups, screening for cancer, encouragement of the exercise, healthy eating, and predictive risk scoring based on the medical history. So, like, this is not just the medical duty, but we can say preventive healthcare is kind of a social and economical strategy because the cost of preventing disease is almost always far lower than treating it after it develops, right? Because once you prevent it, the cost is very less. But once something is break down, then the cost will really, really high to recover it. So in the modern healthcare systems, chronic conditions such as diabetes, hypertension, heart disease, these kind of things will gonna consume a huge portion of the income or huge share of the budget. So yeah, imagine if you could reduce even 10% of those two predictive models using early intervention. So my question here is what kind of disease must be prevented before they start? Any thoughts in your mind? If we could have prevented them before it getting started,
Like
audience?
hypertension, diabetes.
Yes.
Then for
Apart
some
from that,
condition, like some viral infections, like
mm-hmm.
hepatitis. So for that, vaccinations are available, which can be used as a prevention for the condition.
Yes, yes. And apart from that, any recent situation in your mind in last 5 years?
COVID-19,
Of course, yes. And apart from that,
many condition,
anything else?
ma'am,
Yes.
which can be
So
prevented.
yes, yes. Before it getting so worst, for an example, COVID-19, and the second is July 22, monkeypox disease was there in Africa. Last year it was little bit spread across the world, and this sort of thing that needs to be addressed earlier. So in current world, I must say artificial intelligence is reshaping this field by transforming how data is getting collected, how data is analyzed, and how we deploy the model to prevent the illness. AI processes like diverse health data, making risk prediction, early detection far more accurate than traditional methods. And I must say, like AI is literally reshaping the industry of healthcare, and it is again redefining all the boundaries. And why this shift is important. The two terms I said, reshaping and redefining the boundaries and transforming the field of healthcare. But the reason behind this is the better outcome. If you can catch the disease at initial stage, for an example, let's say a cancer, if we catch it at the stage 1, it would be really great. If we catch cancer at stage 4 or later on, we cannot do much thing. So better outcome, preventing a disease will increase the chance of survival and the quality of life. And the second thing is, of course, it is a cost effectiveness. Earlier you get to know about the disease, you can treat it in a low cost, and then scalability with the technology. Data and AI let us scale individualized prevention and providing advice to millions, not just to the few people, but to millions of the people. So the question is like, think of a disease you or someone you know has struggled with. If you had known that the risk years before, what would you done differently? That is the actual power of AI with the preventive healthcare. If I could have an idea about the disease before a year, I can at least be prepared financially, mentally to deal with the situation and circumstances. Any question till here?
No, ma'am.
Okay, okay. So now now that we understand the core idea about the preventive healthcare, and now let's understand the different diseases over the different age group. So these are some different diseases with respect to certain age group. Let's say children till age of 12 having the common diseases and conditions of asthma, allergy, obesity, ADHD, and ear infection. Um, Age group of teenager can have acne, anxiety, depression, sports injuries, and then young adults can have the mental health issue, reproductive health issues, and then thyroid disease. Thyroid disease is very frequent disease in the in India nowadays. And middle-aged people can have hypertension, diabetes, cardiovascular diseases, prostate issues. And the older adults can have arthritis, Alzheimer, dementia, heart disease, diabetes, stroke, cancer, hearing loss, and the depression as well. So, like, preventive healthcare is not one size fits all kind of thing. A teenager risk profile is very different from the person who is 60 years old. So, like when we see this across the lifespan, it is become very clear that prevention is not an isolation activity, but it is a lifelong process, and AI can provide the personalized safety net. Now, after understanding all these certain diseases across the different age groups, let us understand the prevention levels. So, considering three levels of preventive healthcare, the very first level is the primary prevention, where we prevent the disease onset by using vaccination and risk prediction outreach and lifestyle coaching, well-being coaching. And primary prevention is everything we do to stop disease before it getting start, right? And now AI-enabled health coaching apps are there who push people towards the healthier choices. Then secondary prevention is that catch the disease initially in the early stage and often before symptoms are getting appear. So it could be done through the screening test, diagnosis, imaging, and then predictive analytics. For an example, AI mammography tools are there which can identify early stage cancers and tumors. And then tertiary prevention, which reduces like it is trying to prevent the complication and the progression of the severity of already diagnosed disease. Like think cardiac issue or AI app that monitor medication after a heart attack. And here the question is why AI matters. Anyone? Why AI matters here with this sort of different levels? Anyone from audience? No one? Hello?
Yes, ma'am.
Yeah. So why AI matters? Anyone would like to address few issues here? Because AI augments total three levels. It predicts the risk, it detects the disease early, and then it optimizes the treatment and rehab. This creates a continuous loop of prevention and care. So, what do you see the biggest potential of AI at the prediction stage, early detection, or post diagnosis management? Apart from that, I would like to highlight few issues with respect to disease side again. There is the problem called mental health versus physical health, where we can uh, say, as per research, mental and physical health are deeply interconnected. Nearly one in three people with chronic physical condition also has a mental health problem. For example, a diabetic patient may develop a depression, which make it harder to control the blood sugar. And for another example, depression can increase the inflammation and worst it makes the worst diabetic outcomes. Chronic pain also trigger the anxiety, which further implies the pain perception. Consider the situation where a person is doing job and having some health issues or chronic stomach pain. Now a person can have a different mindset. The pain is still there, but now the another thing is what about my job? What about my money? How much cost gonna be covered by insurance? I don't have more than 10 sick leave per year. What my employer will gonna think of me? And so a number of questions will arise, right? So this kind of things are associated with the mental health challenges. And the second thing is another challenge called, say, content consumption. Excessive social media use is strongly linked to the higher levels of anxiety, stress, and insomnia, especially among teenagers and young adults. Now, AI can analyze the pattern of online behavior, the feeds, and on which kind of reels and shorts a person is spending 5 to 10 seconds, and based on that they will get keep on recommendation of same kind of content. So AI can analyze the pattern of online behavior or wearable data to detect the early warning signs. And there are AI powered mental health apps are there which uses natural language processing to analyze how you type and what you write to detect your mood shifts. Voice analysis can pick up the subtle cues for the depression or stress. And then there is a integrated care models. Uh, for example, imagine a patient dashboard where both blood pressure and the mood score can be appear by side or with the graph or bar chart, and this allowed medical professionals to understand the condition in more practical way. So my question here to audience is how many of you think mental health screening should be a standard part of every physical health checkup, and why? Anyone? How many of you think that mental health screening should be a standard part of every physical health checkup? Audience, I need the session to be interactive. Everyone, hello.
Yes, ma'am.
Yes, ma'am. It could be we must do mental health care before the physical health care, because it might be possible that the patient is not able to express the feelings, and due to
Mm-hmm.
the mental instability, physical recovery might not be that much. But if we care about mental health, we
Mm-hmm.
can improve the if we can improve the health physical also.
Yes, yes, very well said. Anyone else? Anybody else? Okay, so let us move forward. So here is the new question. What are the core requirements for the preventive healthcare? We understand the mental issues, we understand the physical issues with respect to different age gaps. Now the question is, what are the core requirements? I know the gap, I know the where research should be done, what to implement, what is the gap, what is the existing solution, and where to improve. But but what should be the core requirement to implement such kind of things? And where AI can fit here? So very first thing is to have a data. And for that we need to collect and integrate various type of data. For example, electronic health record, image related data, laboratory related data, genetics, data coming from wearable devices, lifestyle and social determinants. So yes, data quality do matters, and data timeliness and authenticity is must to consider. I must say data timeliness is more important, because if I would like to predict the diabetes, I cannot take the data before 5 years or 10 years, because as we are evolving with the technology, um, the diseases are also evolving with the human beings. Diseases are also getting more stronger and stronger. So the timeliness of data is must to consider. It is a key parameter. And then the authenticity, the data we are getting from, we are getting it. And the institute or the organization who is providing the data, whether they are the authenticate or not, who is selling the data, whether they have taken the consent of patients or not, whether the data is actually legal or not, and after considering all the aspect, whether the data is true or not, or anyone just has the create a dummy data to sell it out. So data collection is the biggest challenge, and then the integration of data is the another challenge. And then AI comes into the picture to analyze the patterns, whatever data is getting being collected. Machine learning and deep learning algorithms are there to identify the patterns and the risk factor for the early signs of the disease. Then the risk stratification is come into the picture, where it gives the flag to the high risk individuals before before any kind of disease appear. For an example, heart attack or cardiovascular diseases or diabetes. Um, After that, we can consider, as once we analyze the pattern, we flag the risk, we must have the personalized interventions where tailored prevention plans are there, lifestyle coaching is there, and targeted screening must be taken into the account. And then continuous monitoring will take into the place, where real-time alerts will come from the wearables or the mobile health, because I must say, whatever healthcare algorithm we are creating, whatever model we are training, and whatever use case we are solving, if we could not deploy it anywhere, then there is no such use of it. So the continuous monitoring through the real-time alert via wearables and mobile health apps, and then population health management, which gonna predict the outbreak resource need, and at-risk community. So that population health management, and I must say the at-risk community means we are here not only talking about human beings, but the all the community who is at the risk. We say there is a ecosystem, there is a cycle of environment, and where we must say some animals, some bird species, or even some insects are disappear, then that community is at risk. Hello? Hello? So yeah, this kind of population health management is also required, where at risk community needs to be figured out. So moving forward, uh, again, coming to the main topic, AI in preventive healthcare. But now focus is using only what? Using data to stop the disease. So AI plus data can shift the healthcare from reactive to the proactive approach. I must say model needs representative, well-labeled data. And if risk model is trained on only and only urban data, electronic health record from the urban area, then model will surely fail in rural clinics. If model is getting trained to predict the diabetes, but the sample size or the data is taken only from the Gujarat, then that particular model will surely gonna fail if you implement it in a North India or South India or any other state of the India. So by predicting the risk, enabling early detection and guiding scalable prevention, but only when the models are validated, equipable, and integrated into the clinical workflows. So clinician like doctor need to trust the model output with respect to the feature importance and attention maps. We will gonna understand these things in later on slides. But here the key point is data. Spread of the data. If you plot the data on a bell curve, you can understand what is the spread of the data. And the label data is must. When your model must train on the different demographical data. If your sample is coming from the very little space, I said Gujarat state only, it will not gonna work outside of the Gujarat. So let us consider first the data aspect. So these are the different types of data sets where we can understand here from where we can find and collect and integrate the data set to create any model or develop any model from the for the use case of preventive healthcare. This is called electronic health records. That is the structured clinical document, visit histories, medication list, allergies, vitals, diagnosis, and treatment plans. Anyone from audience, can anyone tell me which kind of AI models we can use with EHR? Or what sort of use cases we can target with this kind of data? Anyone from the audience? No one? The second part is the medical imaging, where we consider X-ray, CT scan, MRI, ultrasound, pathology slides, and the image annotations. Now, anyone has a thoughts like where we can use this medical imaging? What sort of application or use cases we can target? Then we can have the laboratory test, blood chemistry, urine analysis, microbiology, pathology, and molecular diagnosis. Then genetic data, where DNA, RNA, protein sequence will be considered to identify the cancer series, gene panels, heredity risk, wearable and sensor data, smartwatch is Apple Watch, glucose monitor, Fitbit watch, and we have n number of devices which monitor heart rate, sleep, movements, activity tracker, home health sensors. Then we could have the lifestyle data where patient reported data on diet, exercise, sleep habit, substance use, stress, and wellness behaviors. The next type of data is the social determinants of the health, where information about social economic status, education, housing, employment, family, social support, neighborhood, and access to care. This sort of thing is determined. And the next data is administrative work related data, where it is a collection of the data of patient where admission and discharge records are there, billing records are there, insurance details are there, scheduling and the resource management related all informations are there. Then I can say mental and behavioral health related data, where psychological questionnaire, evaluation, therapy notes, and behavioral observations are there. Clinical and research data are there, which having the outcome of trials, biomarker studies, registries, and the population health research. Next is the emergency and acute care data, where emergency visit, trauma records, acute diagnoses are there. Then non-admitted care data, just pay attention here. Non-admitted care data is the kind of data where telehealth come into the picture. Western countries such as US, UK, Australia, New Zealand, Europe, where patients are avoiding to visit the hospital due to time constraint, and they book appointments online, and then outpatient clinical records, telemedicine encounters, and the home visit and consultant, all these sort of um, data is stored in non-admitted care data, where only contains the record of patient who take the online appointments, who consult the doctors online on video calls, and then they take the prescription via email and get the medication done from the nearest pharmacy. Another data is teaching, training, and research data, where data is used in medical education, clinical skill training, and simulation environments. And then the admin and financial data, where payment information, mediclaim, cost analysis, and reimbursement codes are there. So till now we have covered different type of data sources, all sort of data types. And now coming back to the AI algorithms used in healthcare, where we can um discuss which sort of AI algorithm we must apply, because we have discussed range of data sets. Now we have data set, but now we need to understand which sort of AI algorithm will work for our data. So AI algorithm used in healthcare, for example, machine learning, deep learning, natural language processing, generative AI, nowadays agentic AI, and then multi-agent systems, everything. But let's review algorithm and where they fit. So for the traditional machine learning algorithms such as decision tree, random forest, XGBoost, CatBoost, support vector machine, all this sort of algorithm is excellent for only tabular data. And tabular data in terms of the data is very well structured data, having a very good structure across row and column, and interpretation will be there. So this sort of data will use for the predicting risk. But again, the machine learning algorithm has their own limitation. They cannot work with the unstructured data. What do you mean by the unstructured data? Means the data come up with the JSON file or PDF or X, apart from the row and column format, all unstructured data. And coming towards the deep learning model, we have the convolutional neural network, recurrent neural network, and transformers. All these sort of neural net family is good for the image, medical imagery data containing CT scan, X-rays, um, pathology scans. Um, Also, the recurrent neural network, I must say, it's a time series related data where we have a continuous data called ECG data, or let's say glucose monitoring. So this model are typically need a large data set, but it can learn the complex features automatically. That is the key difference. Like in machine learning, we need to do a lot of pre-processing to extract the important features. But here, the deep learning model, they extract the features automatically by applying so and so filters. And then natural language processing come into the picture where it converts unstructured clinical notes, radiology reports, and the patient messages into the structured, well-informed data. So yes, NLP will work when the data is very unstructured or just say PDF or documents. And after sorting out with the unstructured data, generative AI takes over where it summarizes the long clinical notes and drafting the patient information and automating the routine documentation work. It is helpful for the workflow, but it is the drawback of the generative AI model is it always hallucinate. What is the meaning of hallucinate is a model is getting trained with the specific data, let's say August 2025. But now from 1st September to 19th September, 19 days of data is missing in the training part. So now if you ask any question to the LLM, it will try to generate answer, but it doesn't have the recent data. So it will generate the answer based on whatever data it has. So it just start hallucinate. It is producing the wrong answer. So it is the issue with the generative AI. So the conclusion with the AI model is no single AI algorithm is a silver bullet, I must say. The real skill is to choosing a right algorithm for the right use case, validating it thoroughly, and ensuring that models are interpretable and auditable. Because once you deal with the healthcare data, you cannot claim it is a AI or it's a black box. Nobody knows what goes inside and how it is producing the answer. You must be answerable in terms of the accountability of the answer, because if AI is saying take so and so medicine, and if patient is taking that medicine and then patient has getting some worst condition due to recommended medicine from AI, who is responsible? So in healthcare, the model must be interpretable and the auditable. Any questions so far? Because from here we will going to discuss the real-time research, a total of 5 case studies. Any questions so far?
No, ma'am.
All good. So this is some use cases. These are plenty of use cases are there, but would like to discuss few of the use cases where uh, we can say AI could be used for the chronic disease management, where personalized care and reduced hospitalization will come into the picture. Then improved hospital administration and operational efficiency, early progression or intervention where spot the worst condition on early basis to prevent the complications. Then predicting suicidal attempts, identifying high risk patient via EHR, natural language processing, enabling timely support. Then forecasting no-shows means predict missing appointments, the missed out reminders, and the optimization of the scheduling. Preventing readmission, it is providing a flag high risk discharge. If person is getting discharged and then person needs to be getting again readmission into the hospital within 30 days. So this sort of things, and then um, preventing issue of security in terms of by enhancing cyber security with real-time monitoring and detecting anomalies in the network or access log and prevention of the breaching of the electronic health record, I must say, and predicting patient preferences, personalized care, appointment times, and communication challenges. So also one of the best use case is handling insurance claim where automatic claim processing, coding assistant, and fraud detection. Now my question is that from now onwards, I need a session to be very interactive. Based on the data we have discussed, there is 10 to 12 types of different data. Uh, can anyone say if I can have a imagery, medical imagery, let's say X-ray images or let's say skin lesion samples or pathology slide photos, what sort of AI model I can use? Anyone? Audience?
Ma'am, can you repeat the question?
So I said like we have discussed 12 to 20, 10 to 12 different type of data sets, right? Earlier in this session. My question is I have a imagery, medical CT scan or X-ray, or let's say skin patches. What sort of AI algorithm I can use for the prediction task or classification or detection task? What sort of AI algorithm should use or what AI model will you gonna select if you have a CT scan images or X-ray images?
Generative AI, ma'am.
Yes,
Generative
um,
AI can be used.
yes. And apart from that, like let's say I just need to classify the images. Yes or no? What
And
sort of model I
SVM
should use
algorithm for the supervised learning, SVM algorithm we can use.
for image related data?
Yes, ma'am.
Okay. Anything else apart from SVM and generative AI? Any middle way? Because machine learning related algorithm ask demands a lot of pre-processing. First of all, we need to convert the image into Excel file. So the value of each pixel from the image will gonna take place of every single cell of the Excel file. So what could be the algorithm that can help me to reduce the pre-processing steps? Any general thoughts? SVM will work for sure.
We may use a deep learning or CNN model.
Perfect. Yes. Yes. So considering this scenario, this is the case study one where we discuss COVID versus not COVID classification from the lung X-ray images. Uh, just would like to discuss on this part. So first two images is COVID and non-COVID, and then the second three images is COVID versus pneumonia versus non-COVID. And imagine this need to classify this kind of images. What sort of model we can consider then? I just want to supply the images to the model. Model will automatically extract the features and then it will do the classification, right? If we can go to the keras.io website, you will gonna find a list of models where you just need to supply the data, model will predict. But the real catch in the healthcare is the default model, the default structure of model will never gonna give you good answer. You must need to modify the model in such a way that model produce a very well trustful result. So here, this is the common structure of convolutional neural network, where input data is there, and this is the very default structure of convolution neural network. What is the default structure is, we can say three layers of convolutional, followed by flattened layer, followed by two fully connected layer, and then end layer is a softmax layer. And then it will, based on the probability, it will round off and predict 0, 1, or 2. 0 means certain class, like it will encode. 0 means normal, pneumonia means 1, or COVID means 2. It will encode with the numbers, the categories. But here the catch is, we have the convolutional neural network. Very first layer is convolutional layer, followed by the ReLU activation function, followed by the max pooling layer. All the time filters are getting applied on the model, the images are getting calculated, and feature map is getting extracted, right? But when we move to deep learning or generative AI related models from the traditional machine learning model, the very first challenge is the optimization and the resource. Every time we cannot use free 50 GB GPU from Google Colab, right? We need to optimize the algorithm in such a way that it will produce the result with minimum iterations and time complexity, space complexity, and resource. All these things needs to be into the consideration. So here the catch is, by default in convolutional neural network, the max pooling layer filter is 2 cross 2. What I have done is I have modified the max pooling layer here. So considering this part, 2340153 this is the pixel of my image, where 2 cross 2 means what? You are taking 2 cross 2 matrix here, and max pool means what? You are taking the maximum value from these parameters. So maximum value here is 5. From this, what is the maximum value? It is a 4. From next matrix, can anyone tell me this orange matrix, what could be my max pooling value? Anyone from the audience? What could be the max pooling value from this feature map? It could be the 4, the maximum value. So now the iteration is getting so much and you're getting very small feature map. What we have done is just modifying the max pooling layer. And instead of taking 2 cross 2, now we are considering 3 cross 3 to getting a good big feature maps. Because the COVID-like situation where millions of people are getting affected, and we need a solution where uh, without interaction with the radiologist, a person can get to know whether the X-ray contains infection or not. This sort of solution is required. So yes, this is the series of CNN model where we apply the images followed by mixed polling layer. But yes, the max polling layer was modified from its basic structure to the 3 cross 3. So if anyone is interested in this sort of research, then you must consider few things like tune the model, not in the traditional way. This is called the traditional way, where you split trend test. The first confusion matrix shows 60-40 trend test split. The second is 70% training and the 30% testing, and then 80-20 split. Trend test split is a kind of hyperparameter tune. I agree, that is the hyperparameters, but number of epochs, or you increase the number of layer, you decrease the number of layer, you apply various trend test splits to get the result done. That is the very common tuning, I must say. You need to tune the default model. Whatever the structure of model is there, you need to alter it out. And that is the main fundamental and magic behind deep learning models. So yes, this is the results from COVID versus non-COVID and COVID versus pneumonia versus normal. But the key aspect was the modification of max pooling layer. Then second case study is the monkeypox disease classification from X-ray images. Uh, why monkeypox disease? See, COVID-19 was so severe. So many people
Hello,
dies. Hello? Yes?
ma'am. There is one question in the chat from Dr.
Yes?
Mehul Barot. How would you
Yes?
decide exit testing and training ratio?
Based on the experiments only, uh, because it's a totally random split. So we can only consider different trials. I must say, starting with the 50-50 ratio, and then the standard practice is increasing 5% in each trial. So you can take 60-40, then 65-35, 70-30 till 95 to 5%. And 95% data goes into the training, and rest 5% will use in the testing, and it is validated because when you launch your product, when this AI model getting integrated into any system, the pilot testing and trials will be there. It is not directly coming into the usage to the people. So the clinical trial will also get some pilot testing. So 95% of data also you can take. But the key consideration is the train and test split must be random. Random splits will be there. And uh, since last 5 years, people are considering 70-30 is the standard split, but no, it is not the standard split. The more data your model can have, it will learn more on that. But just to understand, you need to prevent the overfitting as well. Any other questions? Any other questions? Hello? Hello?
No, ma'am. No, ma'am. Thank you.
Yeah. So my question to the audience is why we are concerned to predict the monkeypox disease? Because monkeypox is not that so severe like COVID. But why research community has a good interest to predict zoonotical diseases? Because before revealing the true answer, I just would like to have thoughts from the audience. Anyone? Anyone from the audience? Any rough idea? Any rough guess? Anyone from the audience? What is the similar kind of disease to the monkeypox? It is a chickenpox, measles, pimples. But if we cannot trigger this particular new virus, then after monkeypox is something new severe come into the picture, we won't be able to predict it out. So whenever the new disease arise, preventive healthcare must it is focusing on that whatever existing diseases are there, and the new disease has the 50-50 similarity, then they will gonna consider it on the prevention. WHO has already uh, pushed the guideline towards this, whether any new disease are there, and even it is not severe, but it must take into the consideration. The next case study is the white blood cell classification. When you can see the white blood cell, this is the microscopic image data, where the first image is the cyanophil, second is lymphocyte, third is monocyte, and fourth is the neutrophil. Now, now question here is, what is the purpose behind the classification of this sort of images? So the simple answer is every white cell has its distinct type, size, and the fractions. You can see there is a three fraction in neutrophil image D, where the image A has a two fractions. Now, if some uncertainty is there in the size and fraction and shape of particular white blood cell, early prevention could say that the person can have a chance to develop a blood cancer or some other issues in a body in later on part. So this sort of research is also ongoing. Now this data is still available on Kaggle. The quality of data was very rough. Even though applying lots of pre-processing, the accuracy was not improving. So the convolutional neural network, which has the default by default three minimum layer is required, but I have tried 4 layer, 5 layer, 6 layer till 14 layer. The accuracy was not that so improved. So what I have done is I have dropped 1 layer and make only 2 layers in the convolution. So 2 layer convolutional network is treated considered as SVM, but the key catch is I don't need to do pre-processing work because convolutional layers will extract the feature and the complexity will consider for only SVM related work. So this is how you can modify the model with respect to the certain use cases. All these three research are published. You can Google it out and publications are there. Next case study I would like to discuss here is the current issue called diabetes. After COVID-19, we can say person having in the 20s and 30s, they are also developing the symptoms of diabetes. So very first important factor to taken into the consideration is the demographic because uh, as per the WHO guidelines and the modern lifestyles, Western countries has the final statement that person will have 30% by default obesity. So this is all about BMI, obesity. Diabetes now is not only the concern of sugar level spike or glucose level spike, but it is also considering gender, race, ethnicity, cultural barriers, marital status, regions, um, social support, education status, economic status, health insurance, and then psychological factors such as depression and fatalism. So, diabetes related issues are nowadays taking n number of parameters to consider, and Delhi aims focusing on the early age type 2 diabetes prediction. The main concern here is now if I train my model with the data of Gujarat, it will not going to work here in Melbourne because the obesity is the new concern and food habits, lifestyles, daily exercise routine, and the pressure level. The mental health is also one of the key consideration. So imagine we want to build a product where demographic related parameter needs to be considered and we need to launch that product. What could be the pipeline of my AI product? So this is one of the best example I must say. The very first variable is the diabetes binary where we can say this is the target feature 01 whether a person can have a diabetes or not. And then the rest of the features are there, including hyper blood pressure, cholesterol, BMI, smoking habit, physical activity, heart disease, fruit veggies, diet, having a alcohol consumption or not, and many more. But the key part here is that starting with by collecting the data set, then do some pre-processing, removal of the duplication, and the most important part here is the feature extraction because feature plays very important role while predicting the diabetes. As I said, it is now not only based on the glucose level or sugar spike levels. So feature engineering is must, and then you can split your data into trend test. You can apply 10, 15, 20 different classification model to classify whether a person can have a diabetes or not. But from here, comparison of the different model, the game is changing. You could have a total of multiple 3 or 4 model which provides the best result. Suppose I have applied 10 models and 2 to 3 models giving me the best result. Now from that 2 to 3 model, I can combine those 3 models, develop hybrid approach, ensemble model, or I can also deploy it for the validation using, and I also need to analyze the sharp values which provide which particular feature is contributing to give me the answer classification and probability of 1 or 0. So this is how the whole pipeline can be worked. And as I said, feature engineering is most important thing, and my favorite one is the by default random forest, which gives a very good feature importance over the multiple feature. Considering I have 100 feature, 200 features, random forest is providing the best feature importance score. Apart from that, you can consider lasso and ridge linear regression models, which automatically down the irrelevant
Excuse me,
or
ma'am.
yes, ma'am.
Sorry to interrupt. There is one
Yes.
question in chat box.
Yes, I am
Which fact?
unable to see the chat
Yeah.
box. Yeah,
Okay.
tell me, ma'am.
Which factor affects more about obesity, diet, or
Mhm.
genetic or daily lifestyle?
Which factors? Hello? Hello?
Hello. Which
Yes, ma'am.
factor affects more about obesity, diet, or genetic or daily lifestyle?
I must say daily lifestyle because on a sample space of 0 to 100, considering 100 people data is there, very only I can say 2 or 3 people which they will consider that heredity. Nowadays, diabetes is there due to heredity, but 90% of the time diabetes is coming due to stress level and obesity. And obesity is coming from both stress and the daily food and diet habits. So it is all interconnected. But ultimately,
And
nowadays here
in
in
AI model, which factor
yes,
affects more? In AI model,
yes. In AI model, the maximum affected part is the obesity. Because here you can also see the feature importance map. The most important and highest correlated feature is BMI, body mass index. If somebody has the very good height, but against the height, the weight is very, very high, then it is out of the BMI range. And the once a person gets the obesity, uh, the fat level of body will gonna increase, which lead the cholesterol issues, and due to the having a fatty liver or increased fat around the stomach area, the pancreas is the organ which balance the glucose level of the body, and then pancreas will not be able to produce the insulin. That insulin which the liquid, the insulin created by produced by the pancreas, it will balance the sugar and glucose in the body. So you may have heard about a person can having a diabetes and its sugar spike is not getting into the control. A person is taking the injection of insulin, right? This is the whole cycle. I hope you get the answer. Hello? Hello?
Yes, ma'am. Yes, ma'am.
All good?
Yes, ma'am.
Yeah. So this is all the feature importance part where we can find what is the most important feature which features to take while model training and which feature to discard straight away. And this is what I can say is the accuracy of all 10 to 15 different models. And you can also combine multiple model and create your own hybrid model. So, and this, yes, hello, hello. This is the next case study where we can say addressing the mental health. So, since last decade, I must say the AI has a good incorporation in field of the mental health, and this is the record of the publication, which is increased over last decade. There are total of 7 AI-powered tool for the mental health care related use cases. First tool is Cogito, where real-time AI coaching for customer service, emotional intelligence enhancement, and empathy training is there. And the main use case of this is the AI coaching system. Another is the Headspace, which is a mental wellness platform, which provide the different use cases on the meditation and mindfulness programs, virtual mental health care services, guided therapies, and psychiatrist support. Another is Limbic, which is the healthcare automation tool. It provides the very good AI automation for the mental health professional, documentation management, patient engagement, and enhancement. Another tool is the Replica, that is the kind of a chatbot for the virtual AI companion, emotional support, conversational engagement for the loneliness and the social isolation. There are three more tools. TechSpace is the professional therapy platform where AI-powered therapist matching is there. Text, audio, video therapy sessions are there, and it is the experts over there in a talk space is the licensed mental health professionals. Another tool is the Visa, where it's a chatbot again, which is a AI-driven chatbot for the mental health support, self-help tools, stress and anxiety management. And another is the Uper. It is another chatbot for the personalized AI guided therapy and mood tracking. So these all five different use cases are there, including classification of COVID by um, modifying max pooling layer, then the white blood cell classification, monkeypox identification, diabetes disease machine learning pipeline, and then the mental health related AI powered tools. Now, the question is, what sort of implementation related challenges we can have? We know the use cases. Now, we also know that don't use the by default models from keras.io. You can tune the model to produce good result in terms of time complexity, space complexity, optimizations. You don't need to apply 100 epochs. You will have the result in 20 epochs if you modify the model very well. But now the question is, what is the implementation challenges? So very first is the data shifts. And can anyone tell me what do you mean by data shifts from the audience? Any thoughts about data shifts? Anyone? We have already discussed that AI model train on the historical data or site specific data, and it often struggle with the new unseen data distribution. So if demographic changes, if my model is getting trained on Gujarat data, it would not gonna work in US and Australia, right? So new devices will require new data. So like this cause the performance degradation and risk unsafe, biased decisions, continuous monitoring, transfer learning, and model updating is required. The second issue is the bias and fairness. If my data has a, let's say, I have 100 data and 80 data is diabetic and only 20 data is non-diabetic. Now model will behave like biased. The decision is always biased because 80% data is already in the majority class. So algorithm may conserve the existing inequality by misallocating healthcare resources, affecting patient trust and safety. And the another issue is the interpretability and clinical trust, where lack of transparency in AI decision making. As I said, we cannot say it's a black box model and nobody knows what's going on inside the model. You must have some answer, right? This sort of thing reduces the doctor's ability to validate and trust the prediction of AI. Another issue is workflow integration and alert fatigue, where poorly integrated AI tools disrupt clinical workflows, causing alert fatigue and resistance from the healthcare staff. Seamless integration with EHR, yes, EHR data, electronic health records, user-friendly interfaces, and the targeted alerts are vital to minimize the burden and maximize the benefit and the profits. And the last, the most important one is the legal, privacy, and regulatory framework. Because in healthcare, like the patient's data, patient privacy is more concerned always. So AI in healthcare must comply with the state and data privacy laws like HIPAA or GDPR, ensuring patient confidentiality through the encryption, access control, and the consent. So this is all the challenges which everyone will gonna face while implementing any product in healthcare. Uh, so what should we do now? What should be the final thoughts? So for the final strategy is that whatever data you are taking, you need to validate the data. You need to check the authenticity of data, and data must have some timeliness so that check your use cases, check your requirement. If you need to predict heart diseases, you need to predict diabetes, or you need to predict any preventive healthcare diseases, check your demographic, check your region, check your area, and based on that, use the data. Whatever data will be utilized for the model training, that particular data is only corresponding to the specific demography. It is not the universal one-stop solution. Then the model we are using, it must be fine-tuned. Do not consider Keras.io models, default models. I have a data, I apply, fit the data, and then I just train the models, and my research is done. Any research, not the healthcare, any research will not gonna work like this. It is kind of, even it is not considered as applied research. You took the data and you fit the model and your job is done. No, you need to tune the model. You need to understand the interpretation of the model, why validation loss is huge, why error is there, why error rate is not getting down with the huge number of epochs, where my model is getting overfit, where my model is getting underfit, where my model is throwing uncertain behavior. Everything is dependent on the fine tuning part. And then there is the validation. Even though you are satisfied with 100 and 150, 200 different model fine tuning experiment, you should not conclude that model is validate and output is satisfactory. You must go for the user testing, manual pilot testing before put it into the final production launch, because you are dealing with the public health and it is never be acceptable and the if the result is compromised, then um, who will be the accountable for this? Who will be the responsible for this? The data provider? No. The person who has the tuned the model? No. the person who has approved the model. No, everybody, because this is the responsible job. It is the joint responsibility, data, ethics, and safe AI. AI with the governance. So, any questions so far? Any questions so far?
No, ma'am.
Um, okay, this is all from my end. Thank you so much. Majority of the research I have discussed today it is already published. If anyone needs to have any doubt or in future you need any suggestion for model related work, not only in the space of healthcare but any space, you can reach me out through the my LinkedIn. This is the QR code. This is the used references, especially for 7 to 11 is more regarding the collection of data sets and from where you can get the data. Majority of the research, as I said, the papers are already out. You can read it out and you can always welcome to connect and
Ma'am,
discuss the points.
there is
Yes,
one
ma'am.
question in a chat box. How
Yes,
to get
yes.
breast cancer data for research?
Uh, WHO has all the repository. Apart from that, you can go to data.government.in and the same data is also available on the Kaggle. But again, the concern is just check out the timeliness of the data. If data is older than like it is a before 2020, do not consider it. Only consider the recent data. Also, if your research is good enough and you will get the letters from the authority, you can reach out the hospitals because Ahmedabad Civil Hospital is running free mammographical test across the various organizations. So you will get the data if you have the permission and letters. And the free source data is also there on Kaggle, WHO, and data.government.in.
One more question, that is the success of model depends on which parameters, or
Huh?
we can say that what factors affect performance of AI model?
So the success of model is dependent. I can in my all research and experience till the date, very first thing is the data only. Because it's a famous quote, garbage in, garbage out. So whatever the efficiency of and quality of data, model will produce sort of answer. And the second stage after confirmation on the data is the model parameters and tunings. Yes. Data pre-processing, the answer is to Kiran M. Jha. The data pre-processing it's a just providing a technique to improve the quality of data. But when the data is just having the sort of pathology slides I show you in white blood cell classification research. On that data, you apply any kind of pre-processing things, the improvement will not be there. So, because ultimately it's a image and it's a pixels there. And if the pixel range is not in the diverse range of variety, it won't produce a good result. So the data quality is important. And then the second is model tuning. And next question is which is the new research area in health issues in future? So the new is very trending is the mental health because nowadays we are consuming so much social media content and and the content we consume our brain functionality is doing the same. So after releasing the feature of reels and shorts in Instagram and YouTube, the mental health issues are there. And now due to the generative AI, uh, there is one famous research ongoing, like people using the chat GPT and generative AI tools. the frontal lobe analysis is there, and the such neurons of mind is not getting activated, and the person is completely dependent on the ChatGPT and generative AI tools. Eventually, the next generation will lose the thinking power. It will be so much dependent on the AI tools.
Thank you so much, ma'am. Is there any question?
No, ma'am.
Okay. Uh, Thank you very much, ma'am. Thank you very much for your support and for sparing your time and giving this wonderful session. It was really interactive and it was wonderful session. Thank you very much, ma'am.
Thanks to you to give me this golden opportunity to showcase my research and connect with more people. And everyone in this meeting is always welcome to connect over the LinkedIn to discuss the future potential of the research. And um, I'm very grateful for everyone to give your time and patiently you listen all the research.
Thank you.
Thank
Thank
you,
you very
Pooja
much, ma'am.
ma'am.
Thank you.
Bye.
Bye. Good night.
Good night. It's 2 a.m. here.